The rain came heavy, and the golden toads answered. Across a handful of shallow pools in Costa Rica's Monteverde cloud forest, more than 1,000 males blazed like embers dropped into wet moss. They'd waited all year underground for this signal. Now the forest floor was a riot of silent, urgent color. Each male wrestled for position in the shallows, trying to clasp any arriving female before the next one did. The females came slower, larger, their dark skin scattered with scarlet spots like splashes of warning. When a pair locked together, the female released a string of eggs into the water, and the water itself seemed to thicken with the weight of the next generation. Stand at the edge of those pools, and you'd believe you were watching something that would never end. But this was April 1987. The spectacle was a farewell. The mist that fed this forest was already thinning, the dry season stretching longer each year. And something else had arrived in the water, a microscopic trespasser no one had yet named. Within 2 years, not a single golden toad would remain. The pools would be silent, the embers out. What turned an abundant protected species into a ghost so fast? The toad was already ancient when J. Savage first saw it. Not the individual animals, they lived maybe 10 years, but the lineage. Golden toads had been climbing out of those same rain-filled hollows since before the last ice age. A pulse of molten amber erupting from the leaf litter every April for tens of thousands of springs. Savage was surveying a remote ridge in Costa Rica's Cordillera de Tilarán in 1964 when he stumbled into one of those eruptions. Males the color of a setting sun crowded every puddle, their brilliance almost violent against the green gloom of the elfin forest. He collected specimens. 2 years later, in the journal Copia, he gave them a name, Bufo periglanus, the golden toad. The entire known population, every male, every female, every tadpole that would ever exist, lived inside a single postage stamp of cloud forest. 4 square kilometers. That's it. A patch of moss-draped trees and perpetual mist pinned between 1,500 and 1,600 meters on one ridge, in one mountain range in one country. When the Monteverde Cloud Forest Reserve was established in 1972, the golden toad became its emblem, a jewel, protected by boundaries drawn on a map, by fences the world believed were enough. In good years, more than 1,000 adults would emerge after the first heavy rains. The breeding frenzy lasted only days, males wrestling in pools shallow enough to cup in your hands, the water churning gold. It looked like abundance. It felt permanent. But a species whose entire existence fits inside 4 square kilometers isn't abundant. It's a bet. And the forest was already holding a losing hand. The killer was already moving. Not a jaguar, not a snake, something you'd never see coming, a fungus. Batrachochytrium dendrobatidis. Researchers shortened it to BD, a harmless-sounding name for a thing that turned skin into a death trap. B didn't hunt, it drifted. Its spores were microscopic swimmers, each one propelled by a whip-like tail through any film of water, searching for one substance, keratin. Amphibian skin is loaded with it. When a spore found a toad, it burrowed in and began to multiply, forming a cyst that pumped out more spores, which infected more skin, layer after layer, until the toad's own hide became a barrier it could no longer live inside. Because frog skin isn't just armor, it's a lung, a kidney, the membrane that keeps sodium and potassium balanced on either side of a heartbeat. BD clogged it all. Electrolytes leaked out. The heart lost its rhythm, fluttered, and quit. The fungus had been traveling for decades, stowing away in shipments of exotic frogs bound for pet shops and labs, clinging to the damp soles of hiking boots, washing from one mountain stream into the next. It had already erased species in Australia. It had torn through Panama and was chewing its way north. Now it was climbing the Cordillera de Tilarán, closing the distance to a single ridgeline wrapped in cloud, where a golden toad existed nowhere else on Earth. The two trajectories were converging, but whether Bold would win once it arrived wasn't just a question of biology. It was a question of what the sky was about to do. The clouds that had always wrapped Monteverde like a wet blanket began to lift. It started in 1986. The Pacific Ocean off South America turned fever warm, an El Niño strong enough to rewrite weather across half the planet. At the ridgeline, the mist that fed the elfin forest thinned and rose, climbing higher each week, abandoning the toad's territory to a sun that had never touched it so directly. Mist-free days, once rare, became the norm. The air lost its dampness. Moss on the trees crumbled to dust. When the rains finally arrived for the 1987 breeding season, they came light and late. The pools that should have been deep and cool were shallow puddles by the time 1,500 golden toads crawled out of their underground refuges, driven by an instinct with no way to account for what the sky had done. Males jammed into the shrinking water, orange bodies pressed flank to flank, every slick surface sliding against another. A single toad carrying Chytrid spores on its skin now rubbed against 10, 20, 50 others in an afternoon. The fungus didn't need the drought to kill, but the drought handed it something better than virulence. It handed it proximity. Warm days, moist nights, bodies packed into ever-shrinking refuges, sharing everything. The cloud forest had become an amplifier, and the question that would outlast every toad in it was already taking shape. When the last one vanished, would anyone be able to separate what the heat did from what the spores did? Or were they now the same thing? By the time the rains arrived in 1988, the question had narrowed. Not whether the toads were dying, whether any had survived. A handful of males crawled from the leaf litter and took their positions at the pools. They called, they waited. No female ever came. The breeding season passed without a single egg string laid. Martha Crump walked those same pools in 1989, checking every crevice, every hollow, every patch of wet mud she'd memorized over a decade of fieldwork. At a shallow pool near the ridge, she stopped. One male, brilliant orange against the dark earth. He was calling, a faint, mechanical chirp, but the pool around him was empty. No rivals, no mates, no egg masses trailing in the water. She raised her camera and took the photograph that would become the species' last living portrait. He wasn't dead. That was the unbearable part. He was alive, performing the ritual his kind had performed for millennia, and he was already a relic. Crump returned in 1990. She returned in 1991. By 1994, she'd logged thousands of hours searching pools that once boiled with orange. 0 golden toads. Not one. The pools filled with rainwater and dried again, season after season, and the silence held. A protected reserve. A team of the world's best amphibian biologists. And Extinction had slipped through every safeguard they'd built, leaving behind nothing but a photograph and a question that had grown too large for one mountain. Alan Pounds couldn't accept a ghost. He and his team pulled every weather record Monteverde had. Temperature logs stretching back decades, rainfall gauges, the handwritten mist frequency notes only a few researchers had bothered to keep. They laid those numbers against the amphibian surveys year by year, species by species. The collision told a story no one wanted to hear. The 1986 to 87 El Niño hadn't just been a dry spell. It had rewired the forest's climate. Nighttime temperatures climbed. The cloud base lifted, thinning the mist that had wrapped the mountain for millennia. Breeding pools that once held water for months dried in weeks. The toads that survived were forced into the few wet pockets that remained pressed together in densities the forest had never seen. And the fungus noticed. Chytrid operates best between 17 and 25 degrees Celsius. Monteverde's new nighttime lows fell exactly inside that window. Warmer nights, crowded hosts, a pathogen already in the water. The mountain had become a perfect kill zone. In 2006, Pounds published the findings in Nature. The golden toad was not a freak accident. It was the first documented case of climate change and pandemic disease crossing the boundary of a protected reserve together. The paper gave the silence a mechanism, and it raised a question the reserve system was never designed to answer. If extinction can move through the air, how many other species are already standing in the crosshairs? The question didn't stay theoretical for long. In the decades since Monteverde went silent, the same pattern has played out on every continent where amphibians breathe through their skin. Australia's gastric brooding frogs gone. Costa Rica's harlequin frogs, species after species gone. Panama, Ecuador, the highlands of Venezuela, each lost creatures that had survived every extinction event the planet had ever thrown at them. The Chytrid fungus, handed its opening by warming nights and shifting cloud lines, has now touched more than 200 amphibian species. Some it thins. Others it erases completely, sometimes before anyone can publish a paper describing what they were. The golden toad was not the rarest, not the most isolated, not the most fragile. It was simply the one that fell first while the cameras were rolling. And what it left behind was a truth the conservation movement had spent a century dodging. A boundary on a map is not a shield. It's a line drawn in pencil on a warming world. The threats that took the golden toad don't need roads. They ride the air. They hide in the mist. They cross into reserves as easily as sunlight crosses a fence line. Monteverde wasn't a failure of will or funding or science. It was a demonstration that the old tools protect this patch, guard that watershed, were built for an enemy that no longer exists. Which leaves a question far harder than how to build a better fence. So the question isn't academic. It's the one Martha Crump asked herself every dry season after 1987. Walking the same trails she'd walked when the pools boiled with orange. Where do you look when the thing you're looking for was never supposed to disappear? The golden toad lived inside a reserve, built to protect it. Scientists knew its name, counted its numbers, watched its pools fill and dry. And still it vanished. The warmth that lifted the cloud base and the fungus that rode the mist didn't pause at any boundary. They moved through air and water and skin. By the time the last male sat alone on that wet black rock in 1989, the quiet apocalypse was already complete 23 years from discovery to silence. Crump kept searching for years afterward, hoping to turn over a log and find one. She never did. But the toad left something behind. A face, a date, and a mechanism. It proved that a species can be abundant one season and extinct the next. Not because we failed to guard its home, but because the threats that matter now travel on winds and in temperatures that no fence can hold. The photograph remains. A single orange body on dark stone, beside a pool that would never host another. And the question it leaves isn't whether this will happen again. It's whether we'll recognize the next one before the pools go quiet.